After the data gets sent down from layer 5, it reaches the transport layer. The transport layer is responsible for segmentation, segment size determination, sequencing, packet type determination, flow control, and port addressing. Segmentation is the process by which the data that is to be transmitted gets cut into transportable sizes. The smallest size that a segment can be is 6 bytes, and the largest is 1460. Sequencing is really the inverse of segmentation. When the transport layer receives the segments from the network layer, they are probably not in the right order, so it must sequence them correctly and then combine the segments into data to be sent back up to the session layer we talked about earlier. There are two types of packet used to send data on the Internet: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP allows for a connection-oriented transmission of data, meaning that there are acknowledgments for the arrival of each window of packets. UDP does not concern itself with such things. It knows that the data must be sent, and so it sends it. Arrival does not concern it. It is faster, but things can get lost in the process. Primarily, UDP is used for video and voice transmission because the eye and ear are capable of filling in the minuscule gaps so that we do not perceive them. This is a TCP packet header. The green part is what is used to initiate a connection, a dialogue, if you will, between the two computers called a three-way handshake. It is also used for the verification of arrival of packets. A sequence number and SYN flag are sent out to request a connection. If this is successful, a SYN acknowledgement is sent back, and then the original computer sends out its own acknowledgement verifying that it received the SYN acknowledgement, or SYN ACK for short. These acknowledgements are what we use to verify the arrival of each window of data. This is a graphical representation of a three-way handshake. The SYN is sent. If received, a SYN ACK is sent out, and then finally the ACK, or final acknowledgement, is sent out from the original computer. I mentioned before that a segment had to be a minimum of 6 bytes to travel across a network. If a segment does not reach this designated size, it is given meaningless bytes, or byte, in some cases, of data, called padding, stored here in the header. Remember when I mentioned a window? Well, that is what we call the number of bytes that a receiving computer can, receive at one time. At first, an arbitrary number of packets is sent out. The receiving computer will then send out a packet stating the one last received. If the number of last sent matches that of the last received, the sending computer will then increase the number of packets. If not all arrive, then it will send fewer. The two machines will repeat this process until an optimal number is found, hence the term sliding window size. Now, if packets 1, 2, 3, 5, and 7 arrive, the receiving computer will still only acknowledge that it received the third. Remember, this same layer is responsible for sequencing the data. And so, packets 4 and 5 will be sent. If they arrive, 6 and 7 will follow. But the new 5 and 7 will be dropped as unneeded. This entire process is what we call flow control. This is what the User Datagram Protocol packet header looks like. Again, It does not care about anything except making sure that the data is sent. If it fails, so be it. Used for audio and video data, though its use for video is becoming less and less frequent because of the buffering delay that UDP can contribute to. The last part of the transport layer that we will discuss is port addressing. We are not talking about the ports on a switch or a router. That is determined at a lower layer. At layer 4, we are concerning ourselves with giving a logical address to each application that uses the network. That way, the data telling the computer where your troll is in World of Warcraft does not get sent to your instant messenger, and your friend's lol response to the joke you just sent goes to IM instead of your web browser. In short, port addressing is used for inter-application transfer, or forwarding, of data.